Okay, for this video we're going to do the 6.3 notes, but I'm going to include this warm-up in the notes as well. Okay, I like this kite problem. So you have a kite, and then below it you have the kite's shadow. So the question is, are these two shapes similar? So we've got to look at the ratios. Okay, so clearly 96 is to 78. Excuse me. So just like, here's another pair, but then look at this pair. Let me just check. Oh, I'm so sorry. Okay, these should be 95s. So let me just quickly fix that. So this is 95. This is 95. Okay, then the last one is 142 is to 132. So you've got to figure out, are these in proportion? So we're going to look right here. Now let me tell you a little trick. If the cross products are equal, so if cross products are equal, then the two fractions are equal. Okay, so I would like to get this down a little bit smaller. So 142 divided by 2, you get 71. Divide the 132 by 2, and what do you get? You should get 76. Let's see. Nope, not 76. So hold on. Go back. Okay, we'll do this by hand. So 132 divided by 2. 2 goes into there 6 times. So 66 is what I'm getting. So I have 71 over 66. Okay, so let's continue comparing them. So we don't need this anymore. So let me get that away. Okay, so now this I'm just going to leave the same because I can't think of anything that goes into both of those. So do your cross products. For these fractions to be equal, then that means that 95 times 66 has to equal, and this is a question mark, 71 times 78. Okay, so do that math. So let me see where I can fit it in. Maybe I can fit it in up here. So if I have, let's see what I'm doing. Okay, cross product, 71 times 78. So 71 times 78. 8 times 1 is 8. 8 times 7 is 56. 7 times 1 is 7. 49. So this is 8. 13. And that's going to be 15. Right? And that's going to be 5. Okay, so that's your product there. Now let's do the other product. So what's that going to be? 95 times 66. Okay, so I have 95 times 66. Let's try that. 6 times 3 is 30. Carry the 3. 54. And 3 more makes 57. Right? And then I have 6 times 5 is 30 again. 6 times 9 is 54. Plus 3 more is 57. Okay, so 0, 7, 5, and 7 is 12, 6. So look, I have 2 different numbers. So since I have 2 different numbers, I know that they are not equal. Not equal fractions. So what do I know? Therefore, my 3 little dots, not similar. Okay, so you would put a similar symbol and then cross it out. They're not similar. Okay, so let's go down to this. In the figure, triangle ABC is similar to DEF, and look at the orientation, they are the same. Indicate what type of special segments are shown as dashed lines. Okay, well those are altitudes. So these guys are altitudes because they come down from the vertex and they make a right angle on the base. All right, so altitudes are in the same proportion as the scale factor when you have similarity. So what is your scale factor? It would be 30 to 36, and we're going to reduce that. So how about if I put 6 into each? So 30 divided by 6 is 5, and 36 divided by 6 is 6. That's your scale factor. So that scale factor has to equal x to 28. Okay, so what are you going to do? You're going to do your cross products. So 6x, and let me do that not here, so let me back up. So for here, so 6x is going to equal 5 times 28. So 5 times 8 is 40, put down the 0, carry the 4. 5 times 2 is 10, 140, and then divide by 6, divide by 6. So 140 divided by 6. 6 goes in there 2 times with 2 left over, right? So 6 goes into 20 3 times with 2 left over. So 20, so let me just make sure I'm doing this correct. So hold on. Oop, I know one problem. Hold on. This number right here is a 35. So let me just go back and clean up this, and then we'll figure out what we're getting. Because I didn't think I had a remainder in this problem. So let me fix my 35. Sometimes it's hard to read these numbers. Okay, so this is not 5/6, but instead it's 5/7. And that's going to make all the difference in the world. So this is 5/7. I put 5. This is... Let's see, this is 6/7. I'm sorry. I put 5 into both the numerator and the denominator. So 30 over 35 is 6/7 because I divided both of them by 5. Okay, so I have 6/7. So 6/7 equals x over 28. So what is 6 times 28? Let me get rid of this. So I need 6 times 28. 6 times 28. 6 times 8 is 48, and the 8 carry the 4. 6 2s are 12, and 4 more makes 16. So I have 168. So now I want to know 168 equals 7x, because I'm doing cross products. So divide 168 by 7. So 168 divided by 7. And 7 goes into 16 2 times. That's 14. Carry the 2. And 7 goes into 28 4 times. So what I'm finding is that x is 24. Okay, because altitudes are in the same proportion to the scale factor. Okay, here's another situation. This is not an altitude. What is this? This looks like an angle. It looks like a median. Sorry, it looks like a median. So go on. So this is a median, right? Because it's coming out of the vertex, and it's dividing the opposite side in half. We just studied those. Those are medians. They are also in the same proportion as the scale factor. So what's the scale factor? It is 27 to 36. And I know 9 can go into both of those, right? 9 goes into 27 3 times, and 9 goes into 36 4 times. So that scale factor is 3/4. So 3/4 has to equal y over 16. So 3 times 16 is 48. So I'm doing my cross products, right? So 3 times 16 is 48, has to equal 4y, divide by 4, divide by 4, and y equals 12. So this is now 12. Okay, that takes us to the next page of notes. Okay, so here's some vocab for 6-3. We're going to prove triangles are similar by angle. So similar polygons will indeed have the same angles, same angle, but different side lengths. Okay, so that's kind of an incomplete statement. So what I really want to say about similar polygons is that the angles, so angles are congruent, and then what else do we know? Sides are in proportion. Okay, that's a better thing to say. All right, so this angle postulate lets us prove that two triangles are similar. So if two angles, so let me make this a little bit bigger, and let me make this, all right, I think we're okay. So if two angles, I don't know why it looks so funny. Let me make this maybe darker. Okay, let me back up. So if two angles, this is much worse. So I guess I have to zoom out. Okay. So if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Okay, so look, you have one angle, two angles. This is why these are similar. So let me get rid of my marking so we can see what I'm actually talking about. Okay, so here's your similarity statement. So you could, and you should practice listing all the equal sides and all the sides in proportion and all the equal angles. So let's really quickly do this. So I have angle K equals angle Y, and I have angle J equals angle X. So if I know that, then I can say that these two triangles are congruent due to angle. Okay, let's go on to the next page. Okay, so this says determine whether the triangles are similar, and if they are, write a similarity statement. So you have some missing angles. So if you do math, so you would have said 90 minus 53, you would get 37. If I know that that's 37, then I know this has to be 53. So these are similar by AA. Write your statement. So triangle, go to the right, go to the 37, go to the 53. Is similar to triangle, go to the right, go to the 37, go to the 53. There you have it. Okay, show that the two triangles are similar and write a similarity statement. Okay, so here you have vertical angles. That's a pair of angles that are going to be the same. Then if you extend these lines gently and recognize that, I guess we'll use this one as a transversal, what happens is this angle equals this angle by alternate interior. So I have my two angles. So if I'm going to, let me just get rid of some of this so I can see what the letters are. There we go. There we go. If I'm going to write my triangle statement, go from the alternate interior angle to the vertical angle to the other angle. And that's similar to, I started with the alternate interior angle, the vertical angle, and then the other angle. Okay, look, we did the same kind on the other page. They share this angle, therefore those two triangles are equal. Start with the unknown angle, go to the shared angle, go to the 44, then go to the unknown angle, shared angle, 44. Okay, so AA made both of those equal. Okay, we have one last thing to do. A school building casts a shadow. So here's a school building, and it casts a shadow that's 26 feet long. At the same time, a student standing nearby who is 6 feet tall casts a shadow that's 4 feet long. How tall is the building? Okay, so since they're saying at the same time, I know the angle of the sun, which is making the shadow, they're both equal. And I'm assuming everything's standing up straight, so you have right angles. So I can now say x is to 6 just like 26 is to 4. And what do I get? 4x equals 6 times 26. 6 times 6 is 36, and the 6 carry the 3. 6 times 2 is 12, and 3 more is 15. So that's 4x equals 156. Divide both sides by 4. And if you do that math, you're going to get x equals 39 feet. So they are similar by AA. And that concludes this lesson. So if you need to go back over this a little slower, go ahead and hit the pause button.